Right, so we're going to be looking at double angle formulas here, but I'm not going to head there directly, not yet. Let's just review very quickly what your definitions of sine, cos, and tan are. So, Tiffany, are you able to tell me what the definition for any angle that is of sine, cos, and tan?
Sine is y over r.
It is, but you probably need to set it up a bit more than that. I mean, what's y and what's r, right? So you need to tell me a bit more.
Wait, what?
So it is y over r, but
Yeah.
I guess you haven't really told me anything. I mean, I just drew a few lines.
Can I just draw it on the graph? I don't really know how to say it.
All right. I mean, so yes, you're not going to be tested on this directly, but what we're saying is you've got a circle, center at the origin, not the best circle ever, but that's...
Oh, how did you do that? Okay.
And so imagine that's a circle, okay? And we've got some radius r, and I assume you all know by now, if we take a line from the center, the origin I mean, which is the center of the circle, and we take some angle anti-clockwise from the right, and we draw some sort of line, like so. No matter which direction that line is, for any angle theta, we're going to hit some point, which we'll label P, which will have some x coordinate and y coordinate. That could be anywhere on the circle. And if we take the y coordinate of P and divide it by the radius r, which is positive, then that by definition is sine. And now we've set that all up. Now you can basically say it's y over r, and that makes sense, right? Okay, so Paris, what is cosine?
X over r.
And what is tangent? Jocelyn?
Y on x.
Correct. All right. So now we have all these things set up. This is revision. Hopefully nothing confusing there. So now keep that in mind. All right. Now I'm going to have, again, my coordinate axes. And I'm still going to have a circle. Which is still going to be radius r. And, I'll still have my ray. I'll draw in blue as before. Now, instead of calling it theta, let me just call this one beta. All right, I'll call it beta, all right? And I'll still call this P. So P will have some sort of x coordinate and y coordinate, right? Everyone agree with that?
Mm-hmm.
Now, it will have some x coordinate and y coordinate, but just to be clear, you guys can, we can either write it as the x coordinate of P and the y coordinate of P. So I can do it like this. Or if you like, guys, you can think of it as it's at AB, where A is the x coordinate of P and B is the y coordinate of P. Whatever way you prefer, it's all the same, all right? So doesn't matter if you think about it as the x coordinate of P and the y coordinate of P, or A and B. Now, what I'm going to do now, though, which is not on the left, is draw another line. All right? So for all intents and purposes, it's just another angle, right? And I am going to call this angle here alpha. Everyone happy with that?
Yes.
So I've got two different angles. One's angle alpha, one's angle beta. In my diagram here, they're not the same, which means I'll get a different point. And I'm going to call this Q, which of course will be, at the x coordinate of Q, which in this case is clearly negative in my example here, but it doesn't have to be, could be anything. And it will be at the y coordinate of Q. And if you don't like using x, y with subscripts, then I guess the other alternative is to think of this as C, D. Same thing, really. Right? Everyone happy with that?
Yeah.
Mm-hmm.
All right. So before I continue on, let's just see. Are you guys able to work out for me the x coordinate of P and the y coordinate of P in terms of, some sort of angle? Are you guys able to do that? Do you guys see where we're heading with this? I want to find some expression for x coordinate of P or y coordinate of P.
What? Sine, cosine, tan?
Something to do with that, yeah. So you have to decide sine, cosine, or tan, which one, right? And also which angle, right? So let's start with x coordinate of P. Do you think we want to work for x coordinate of P? Do you think we want to work with alpha or beta?
Beta.
Right? It makes sense we work with beta because, well, it's to do with
Logic.
P, which is beta, right? So if you are going to be looking at beta, is there a relationship between x coordinate of P and beta?
Yeah.
What is that relationship?
Because beta is beta, x coordinate of P is possible where it is.
Yes, but what is the specific relationship?
Paris, do you know?
Well, you guys might want to consider, you're right, Tiffany, that beta helps determine x, but you might want to keep in mind the things on the left, right?
Right.
So, how about this, right? For any theta, what's the x coordinate? If cosine theta is x coordinate over r, which is this x coordinate, well then,
R cos theta.
x is just r cos theta for whatever that angle is. Does everyone follow? If cosine of theta is x divided by r, where x is the x coordinate and r is the radius, as we said before, then I can simply rearrange to say, well, the x coordinate will always be r, which is the radius, times cosine of theta, whatever angle it is.
Yeah.
Oh, yeah.
And in this case, if our angle is beta, then it follows that I just changed the theta to a beta and I'm done. Does that make sense?
Yeah.
All right. And how do you think we work out the y coordinate of P?
R sine beta.
Right. So if you like, you can look at it in general. Sine of theta, for any theta, is the y coordinate divided by r. That means we could rearrange by multiplying r on both sides to get y must equal r sine theta. But that's for any theta. And in this case, we have it being beta for the letter P. And so it will just be equal to r sine beta. All right, does that follow?
Yeah.
So what do you guys think x coordinate of Q would be?
R cos alpha?
Right. I mean, you can imagine the blue stuff's not here. It doesn't matter if the blue stuff's there or not. Q is just some line, like some point that the green line intersects, and the green line is just angle alpha. So it's the same thing as the left, except I've changed the angle to a different angle, which in my example here is obtuse, but it's just a different angle. So x coordinate of Q will just be r cos alpha, whatever alpha is. And y coordinate of Q, Jocelyn, what do you think that would be?
Sine cos alpha.
Not sine.
R sine alpha.
Yeah. So r sine alpha. Good. All right, so those are the coordinates in terms of alpha and beta, whatever the appropriate angle is. Does everyone, do you all agree that that is, because of the definition on the left, these coordinates must be true?
Yes.
All right, good. So now, the next thing I want to ask is, well, we have this point P and we have this point Q, right? So I want to ask, I can draw a line between them, and that line is called PQ, right? What is the length of PQ? Or how do I work out the length?
You do, you take the xq and you take the xp and you find the difference.
Well, that would be, I mean, that's slightly unfortunate from my diagram here. So what you said would be true is if it was a horizontal line, but there's no guarantee at all it's a horizontal line. So I probably should have picked a different beta and alpha where it's definitely not a horizontal line, but it kind of looks like one, and I can see where you're going with that. So if it was a horizontal line, that would be true, but you can't assume it's a horizontal line because I'm going for any alpha and any beta.
Ah, I see.
And you just use the cosine rule.
So one option that Paris is floating is to use the cosine rule, and let's see if that works. So option one, Paris suggests the cosine rule. All right, so Paris, what is the cosine rule?
It is a squared equals to b squared plus c squared minus 2bc cos a.
Good. All right. So Paris suggests using the cosine rule, which means that, of course, hopefully you guys are all aware because this was part of homework a few weeks ago. When you're dealing with a non-right angled triangle, you have to have a triangle. And in this case, quoting the rule that we've given, we want to find a side. So if you imagine that this here is PQ, if this is PQ, then you need to find a triangle, and that triangle you need to know two of the other sides, and you also need to know the cosine of the included angle. So do we meet those requirements? Do we know what B is?
Yes.
What would B be?
We can find B.
Well, you kind of need to tell me. If you're saying yes, firstly, what would B be? Which triangle are we looking at then? What's our triangle?
QOP.
Yep. So we'd be looking at triangle QOP. Now,
And
if we're letting A be PQ because that's what we're trying to find, then which length is B and which length is C?
They are both R, which is OQ.
Okay, so that's the point. But in case you haven't seen that, B could equal OP and C could equal OQ or the other way around. But as has been pointed out, OP and OQ, as you can see from the diagram, are both radii of the circle. So these are both R. So we do definitely know both of them. That is true. The last thing we need to know, so we know B, we know C, so all that's done. Do we know A?
We have to work it out.
Well, firstly, what does A represent, Jocelyn?
Oh, sorry, what was the question?
What does capital A represent in our example here?
It's the angle. I'm not sure.
It is an angle, but which angle?
the alpha minus that.
So yeah, you're on the right track. So it's angle QOP, which indeed you've noted is equal to alpha minus beta. Yep.
Okay.
Does that make sense?
Yeah.
Good. So therefore, do we have enough information to do this question by the cosine rule?
Yes.
Good. All right. So I want you all to therefore go ahead and do this. All right. Take a minute or 2 minutes and simplify it to the best you can. I'll give you about a minute or so to do it. And if you've got some sort of answer, you should try and factorize it if you can, to as much as you can. All right. Hopefully you've all had time to do that now. Tiffany, what answer did you get?
Sir, why are you always picking on me?
No, I go around the classroom.
Okay, this is for sure not right.
But what did you get? Yeah.
Root cos alpha minus beta.
Like that?
Yeah.
Yeah, you are missing a few things there, if that's all you have. So we'll run through it. But Jocelyn, what did you get?
It's same as Tiffany.
Huh. How did you guys get... You guys know that this is a plus here, right? Like this thing is a plus, right? How'd you guys... Where'd your b squared and c squared go?
Oh.
Together.
I'm not sure where your b squared and c squared went. And also remember... And also
Like
remember I said pq squared, right? To keep it simple, I said pq squared. So I can understand you square rooting if you didn't notice I asked for pq squared, but you don't need the square root if I ask for pq squared, right? I mean, it's just one step there. So Paris, I assume you didn't get that answer, or did you get that answer as well?
I don't know if it's right, but I got 2r squared bracket 1 minus cos a eta minus beta.
All right, that sounds right, I think. So we'll run through it on the board here. And, Tiffany, Jocelyn, I can't see what you did, but let me know where you went wrong, okay? Because I'm curious as to where it happened. So we know we're subbing in R for B and C. So that means this is R squared. This is also R squared. Minus 2 times R cosine of, and we're subbing this in. And R squared plus R squared is just 2R squared. And R times R is again 2R squared. And that's not wrong, but I did say simplify if you can. And hopefully you guys can see that you can factor out 2R squared, leaving you with 1 minus cosine of alpha minus beta.
Oh, okay.
So Tiffany, what happened? Like where did it,
Yeah, I think Justin and I both saw the 2R squared minus 2R squared, and we just minused it.
Yes, but there's a multiplication sign here. There's no plus minus. So, you can't, these two things can't cancel because, well, it's not like it's 2R squared minus 2R squared plus this, right? It's 2R squared times this. So you need to factorize. Yeah.
Yeah.
All right. Jocelyn, that's where you went wrong as well?
Yeah.
All right. So this is an answer for PQ squared. All right. And that's fine. That is doing it correctly via the cosine rule. All right. No questions with that, right? Everything clear? Well, let's go back to this diagram. Let's say I don't know the cosine rule, for example, or I know it, but I didn't see it, whatever. So let's ignore the cosine rule. Back to square one, sort of, and I want to find the length of PQ. How do I find the length of PQ?
Didn't we just do it?
Oh, we did via the cosine rule. And now I'm just saying, imagine we haven't done that and we don't know that and we can't do it by cosine rule.
And it's not horizontal either.
It's not horizontal, no. Do you guys not know how to work out a line that's not horizontal?
Sine rule.
Well, we don't have enough for the sine rule, right? Because we don't know, we don't.
Oh, right. What am I thinking? Okay.
We don't know the other angles. Well, we kind of do actually. So you can, but that doesn't really head where I want to go. So you do actually know these angles because it's an isosceles triangle, but it's not really where I want to head down. And it'll be a bit more complicated based on whether this is obtuse or acute. So let's just ignore that.
Okay.
So if that's giving you a bit of trouble, maybe let me ask you a different question. So imagine I had a point, and I call this x1, y1. And at another point, wherever it is, and I call this x2, y2. And I ask for the distance between them. Do you guys know how to work this out?
Yeah.
How do you work that out?
Oh, it's the distance between 2 points.
Yeah. And what is the distance between 2 points?
X1 minus X2 squared plus Y1 minus Y2 squared and the square root.
Yeah. And do you guys understand why that is the formula?
Isn't it like the Pythagoras?
Yeah, it's basically Pythagoras, right? So, as long as you can sort of see essentially that this distance here would be x2 minus x1, because in my example here, x2 is bigger, but when you square it, it doesn't matter. And this will be y2 minus y1. And so basically, you know, it's Pythagoras, basically, with that triangle. Does that make sense? So as long as you have, you know, 2 points and you know the x and y coordinates, then you can work out the distance using the distance formula, right? Everyone happy with that?
Yeah.
So let's go back here. I've got P, right? Do I have the x and y coordinate of P?
Yeah.
They're down here, right? I have Q, right? Do I have the x and y coordinates of Q?
Yes.
Yes.
So therefore, do I have 2 points where I know both the x and the y coordinate for both of them?
Mm-hmm.
And can I therefore find the distance between them using the distance formula?
Yes.
Yeah. So therefore, method 2, distance formula. Can you guys go ahead and do that? So I'll leave it on this screen with all the coordinates there. Hopefully that will be helpful. But now basically do it again. And as always, simplify what you can. And this time using the distance formula. Now remember, for simplicity, I don't need you to find the distance PQ, just find PQ squared. So don't bother taking the square root. You can, but just keeping it easy, let's just work out PQ squared and not bother with the square root. I'll give you a minute to do that. Are you guys all done?
Yeah. Wait, we don't need to expand.
You do. I want the, you know, you want the as simplified version as you can.
Oh.
Okay. Okay. Of course.
All right, I'll give you another minute.
Well, you know.
All right, Jocelyn, are you finished?
Yeah.
What did you get?
But I didn't simplify it.
Okay, what have you got so far?
I got. I only put the thing into the formula, but like.
Okay, you might need to do a little bit more work. Tiffany, where are you up to?
Right. I'm just gonna read what I've got, and you could tell me it's wrong. R cos squared beta minus R cos squared alpha plus R sine squared beta minus R sine squared alpha.
Yeah, you haven't. So your problem, it sounds like, what's A minus B all squared? How do you square this?
Oh, lol. Okay. Yeah. Why am I so confused? Okay.
So it sounds to me like you've just squared it like this, right? That sounds to me like what you've done.
Yeah.
Except, of course, you realize that's wrong. And it should be minus 2ab plus b squared, right? So you're
really
sort of,
bad. Why? Oh, God. Okay.
sort of missing the middle part there.
Yeah.
Right. So I'll give you guys, Paris, have you finished at this point?
I have expanded it, but I'm not sure if that's the most simplified.
Have you factorized it after expanding it? Have you simplified what you can and then factorized what you can?
I haven't factorized it yet.
All right, I would suggest you do that. If you know, I'm assuming what you're up to is correct. And so maybe try and factorize it if you can. Jocelyn, how are you going with yours?
I'm still doing it.
Wait, but when you factorize it, doesn't it go back to the previous step?
I'm not sure what you mean because I can't see what you're doing. But the way I'm thinking, no. So maybe you're not.
So I got a minus b all squared plus maybe c minus d all squared. And then I've expanded it to a squared minus 2ab plus b squared. And then plus another one.
Yep. Yep.
But then how do you factorize?
Oh, you need to actually expand. You haven't expanded?
Yeah. Yeah, I have extended it to a squared minus 2ab plus b squared. Is that what you meant?
Oh, okay. And then there should be things that you can simplify and do.
Oh.
I am trying not to give too much away. So there are certain things that you should be able to do after you expand. Maybe look carefully. Okay. So what I've got here on the board, hopefully all of you are okay with this. This is your, distance formula. This is just subbing them in. Now at this point, we kind of have two options. We can factor out within the brackets an r, which would actually make your squaring a little bit easier. And we can do that to both of the brackets. Or we can just square it as is. Now, I feel like most of you will probably feel more comfortable if I just square it as is, rather than factorize the r and then square it. So I'll just square it directly without doing any factorization first. But just so you know, if you're comfortable, I'll do it the way I think you're comfortable with the first one, and then I'll show you what I mean with the second one, all right? So with the first one, keeping in mind that a minus b all squared is a squared minus 2ab plus b squared, then that means I'm going to get r cos alpha all squared, which is r squared cos squared alpha, minus 2 times r cos alpha, r cos beta, plus r squared cos squared beta. All right? So that's the first one. And then for our purposes here, because I'm running out of space as well, I'll just expand the second one normally as well. So we'll get r squared sine squared alpha minus 2r sine alpha sine beta plus r squared sine squared beta. Did everyone get there?
Mm.
Tiffany, Jocelyn, did you guys get this line?
Yep.
Yeah.
All right. So because I'm running a bit out of space for what I want to do, I won't write it on a new line. But can you see that this r, oops. Can you see that this r and this r will make it r squared?
Yeah.
And I'm left out an r on the second line, which I shouldn't have. But that r that I'm adding back in would make it r squared. So it's going to be minus 2r squared cos alpha cos beta and minus 2r squared sine alpha sine beta. Does that make sense?
Mm-hmm.
Now, can you guys see that I can factor out an r squared out of everything?
Oh.
R squared, R squared, R squared, R squared, R squared, R squared.
Yeah.
So to make it a little bit nicer, maybe slightly more obvious what's happening, I'll do that. All right, everyone happy so far?
Yep.
All right. Can anyone see anything that we can kind of do to simplify inside the brackets? We factor out the r squared. Is there anything inside the brackets that we can do to simplify? That does not just kind of go backward.
You can do cos squared beta plus sine squared beta equals to 1.
Yeah. You guys remember, right? Sine squared plus cos squared for any angle that's the same is equal to 1. So right over here, we've got a sine squared beta and a cos squared beta, and we're adding them. So that over here is just a 1. Happy with that? Right? It's sine squared beta and cos squared beta. And yeah, I changed the angle to a beta, but it's still the same angle. So from what you've done before, you know, last week and also a long time before, sine squared plus cos squared equals 1, whatever the angle is, as long as it's the same angle. And this is the same angle. So that's a 1, for sure. Everyone happy? That doesn't sound very happy, but it should be true because you guys did this for homework last week as well. Can you guys see anything else? If there's a sine squared beta plus cos squared beta equals 1, what else do you notice?
The sine squared alpha and sine squared beta.
So we also have a cos squared alpha and a sine squared alpha, which would also add to 1. So over here, this is also 1. So you've got a 1 here and a 1 here, meaning you have what?
2.
We have 2. Does that make sense?
Yeah.
And now you can see you can factor out the 2, right? So we'll do that. We'll take out the 2. And you're left with 1 minus, and I'll write it in 2 lines. So I've got this, right? And then for my purposes, I'll write out another line. Oh, yeah. Wait a minute. Yep. All right. So, therefore, everyone happy with all the steps we've done so far?
Yep.
Tiffany, Jocelyn, any parts that you aren't clear about?
No.
All right. So, you guys agree that this is PQ squared, right? I mean, this is PQ squared, yes?
Yes.
You guys agree that this is PQ squared, right?
Yes.
So let me just copy this out again. And I want you to kind of look very carefully. So this is the distance formula version. So anything we notice?
The bracket's different.
Well, yes, but more importantly, what's the same?
2r squared.
2r squared is the same. The 1's the same, right?
Mm.
And these parts are different, right?
Mm.
Now, are these the same thing?
Yeah.
Oh, yeah.
And so, what can we say? Given that these two things are the same, and we know that to be a fact, then what must be a logical conclusion?
The bracket inside the bracket equals the bracket inside the bracket of the other bracket.
In other words, we're saying that cosine of alpha minus beta must equal cosine alpha, cosine beta, plus sine of alpha, sine of beta.
Nice.
Right? We're proving this result.
Oh, okay.
Right? Those two things have to be the same because the top one is PQ squared. We did it by the Cosine Rule way and nothing was wrong with that. The bottom one was PQ squared as well, and we did it the distance formula way. And these two things must be the same thing. And well, that bit that's different has to equal each other. Does that make sense?
Yep.
Good. So now we have this. Now, therefore, this is true for any angle, whether for any angle alpha and any angle beta. So we've spent a bit of time, but at the end of the day, we got this result. Cosine of alpha minus beta for any alpha and any beta must equal cosine alpha, cosine beta, minus sine of alpha, sine of beta.
Mm.
That works for any angle alpha and any angle beta. Now, you're probably not going to get tested on that. You're definitely not going to be tested on the proof, to be clear, all right? Now, I might want to work out what cosine of alpha plus beta is. And I don't really want to go through that level of proof all over again. So I'm going to show you how we can kind of we'll not do all the work all over again, but we can kind of use what we did above, right? So if I want cosine alpha plus beta, and I know this to be true because I've just proven it, then what can I put in bracket so that these are the same thing? And I'm putting negative here because I want to use, the rule above. What can I put in brackets there that would make it equal to?
Negative beta.
Exactly. So think of this as your angle, right? And now now I've got alpha minus some angle, right? And I'll just put it in a different color in case of any confusion. And so now the whole green thing you can think of as that angle there. And I can apply the rule above. So that means I'm going to get cosine of alpha, cosine of the green thing, minus sine of alpha, and sine of the green thing. Happy with that? Now, this is all things we've done using in previous weeks. Although this one's going a bit further back. Do you guys remember how to simplify cosine of negative theta? Like cosine of a negative angle?
Cosine of a negative angle.
Yeah, so basically cosine of negative theta equals?
Cosine theta.
Positive cosine theta.
Oh, yeah, that's what I meant.
Right? You guys remember this from a long time ago where we did sort of the fact that negative theta is in the fourth quadrant and it's cosine, so it's positive, and then you just do theta, right?
Mm.
And so that means this thing, the whole thing underlined in yellow, changes into positive cosine beta. So I'll just write it as cosine beta. Now this leaves us with sine of negative beta. So sine of negative theta. What's sine of negative theta from the rules we kind of learned before?
Negative sine theta.
Jocelyn, Tiffany?
Oh, yeah. That
Any-
makes a lot of sense.
Do you guys remember that at all?
Mhm.
Jocelyn?
Yeah.
Okay. Well, if you guys are a bit rusty with that, you know, I've given you worksheets on it. You need to kind of, and you'll get some more today as well, but you kind of need to go back and just review them. I told you before, you should be doing them daily just because you can repeat them often until you really, really know them, because they will come up. Okay. So that means this is negative sine beta. And hopefully you can see that the negative here and the negative here will then combine and you'll end up with a positive. All right, giving us this sort of rule. So cosine of alpha plus beta equals cosine alpha cosine beta plus sine of alpha sine of beta. Okay.
Wait 1 sec. Oh. Oh, okay. Yeah.
Everyone happy with that? Okay, everyone happy with what we've done so far?
Mm.
Yeah.
Yes.
No questions? All right. So I'm going to fairly quickly run through the other ones because you won't be tested on these too much, but we've now worked out cosine alpha minus beta, you know, over here. We've worked out cosine of alpha plus beta. And now let us try and work out sine of alpha plus beta. Now this one's a bit trickier, so I'll kind of lead you through it directly. But see, I don't really want to do all the proof all over again. I could, but let's kind of work with what we've got. Now, I don't have sine alpha plus beta or cosine alpha plus, or sine alpha minus beta. I've only got, so I can't kind of do this negative trick that I've done before. I'm going to have to figure out a way to convert the cosines, which is what I do have, into a sine. Or I suppose another way is I have to use these rules, right? So I'm going to have to convert the sine into a cosine, I suppose, is the other way to think about it. So if you have sine of an angle and you want to convert it into a cosine, what goes into this bracket here? We're used to going from left to right, but now I want to put something in the bracket here where the answer is a positive sine theta. And so cosine of some angle is a positive sine theta. Does anyone have any ideas of what that could be?
Is it pi on 2?
Pi over 2.
Minus theta?
Yeah. So you're used to going from the, this side to the left, right? You're used to saying cosine of this angle, okay, pi over 2 minus some angle is quadrant 1, so it's positive. Pi over 2, so it's sine. You're used to going that way to this way. In this question here, I'm going from left to right. I'm changing it there. So sine of any angle is cosine of pi over 2 minus theta. And that's what I'm going to use here. So this angle here is going to be put in as pi over 2 minus that angle. All right. Does everyone understand what I've done there? I've used this relationship here to change the left-hand side equal the right-hand side.
Mm.
Now, if I use this rule now, I'm just going to get back here. So that's not very helpful for me. I don't want to get back here. I want to get something like this. So I won't expand using this rule just now. What I will do is expand the bracket. So pi over 2 minus bracket alpha plus beta is the same as pi over 2 minus alpha, then minus beta. But that now means I can group, for example, it doesn't really matter how I do it, but I'll group the first two together. I can group pi over 2 minus alpha as a bracket now. And so if I think of this as one angle, and this is another angle, I can now use this formula up here, the top one, where alpha is this angle and beta is this angle. Okay. And using the top formula, where you know it's cos alpha cos beta minus sine alpha sine beta, that means I'm going to get cosine of pi over 2 minus alpha times cosine of beta minus sine of pi over 2 minus alpha times sine of beta. Does that make sense? So I'm just using the rule up here, cos alpha minus beta. So that's cos of alpha minus beta. And then, cos alpha, cos beta minus sine alpha, sine beta. And so we're now going to have to do a bit of simplification here. Cosine of pi 2 minus alpha, from here we know the answer to that is just, well, sine. Now, what's sine of pi over 2 minus alpha? What's sine of pi over 2 minus alpha? Harris?
Is it like cos something? Cos alpha?
Positive or negative?
Positive?
Yeah. So that means you will just replace this by cosine of alpha times sine of beta. And there you have it. Sine of alpha plus beta is sine alpha cos beta minus cos alpha sine beta. Another one for you.
Whoa. Okay.
So are there any any questions about anything we've done so far? Okay, so we could kind of use the same trick as we did above, to change this, positive to a negative. So I won't write out the working. You can try it for homework if you like. And, it just means that if you sub in beta as negative beta, so this sine alpha will stay unchanged. The cos of negative beta is still cosine beta, so that will stay unchanged. So that will be sine alpha cosine beta. Cos alpha will remain unchanged, but sine of negative beta will become negative sine beta. The negative and the negative will cancel to become positive, so it becomes plus cosine alpha sine beta. So I haven't shown you all the working, but it's basically the same working as this, and the relationships over here. And that is another relationship. Does that make sense?
Yep.
Okay, so I'll write 4 of them out, or 2 of them to start with, on the next page. And you'll notice we've got sine and we've got cosine, right? So we've worked out that sine of alpha plus beta equals sine alpha cos beta plus cos alpha sine beta. And we've worked out cosine of alpha plus beta equals cos alpha cos beta minus sine alpha sine beta. And we've got the negative versions too, but I'll just write these 2 for the moment. So we've got sine and cos. Is there anything we don't have?
10.
Yeah, we don't have tan. How do you imagine we'd get tan?
Sine over cos.
Right. You guys know that tan theta equals sine theta over cos theta for any angle theta. So if I want to work out tan of alpha plus beta, for example, that would just be sine of alpha plus beta over cosine of alpha plus beta, right?
Right.
And we have them right there. So that means it's got to be sine alpha cos beta plus cos alpha sine beta, right? All over cos alpha cos beta minus sine alpha sine beta.
Cool.
Now that is true and that is correct, but normally, we kind of don't want to write this formula in terms of sines and coses. We normally write it in terms of tans.
Oh.
So this formula isn't wrong, but we want to simplify it a bit. We want to get it in terms of tans. And I'm kind of using this as an example to kind of show you what you guys might do with your trig. So you can see that we've got a whole bunch of sines and coses, right? How do you change a whole bunch of sines and coses into tans?
You can do that.
If you've got a whole bunch of sines and coses, to change them into tans, you need to
Do that.
get in the form of sine over cosine.
Oh.
So we don't have sine over cosine anywhere, but that means we need to divide by cosine. And we have a fraction. And so because we've got a fraction, we're allowed to divide both the numerator and the denominator by the same thing. And if we were to divide the numerator and the denominator by the same thing, the fraction wouldn't change, right? So you might not be able to see this very clearly, but I'm going to divide by cosine alpha and cosine beta for numerator and denominator. All right. You could do it one at a time. You could do cosine alpha first and cosine beta next. I'm going to do them together, I suppose. I'm going to hopefully see, let me just, maybe I'll write it this way. It might work out easier for you guys to see. So I'm going to divide the numerator by cosine alpha, cosine beta. So this is the numerator only, right? And then I'm going to, have it all over. So this is your main thing, the denominator, which is cosine alpha, cosine beta minus sine alpha, sine beta over cosine alpha, cosine beta. So maybe that's easier for you to see, maybe not. But the point is we need to divide everything by cosine alpha and cosine beta. Now, this is a plus, so that means this thing by itself needs to be divided by cosine alpha and cosine beta. But what do you notice about the cosine betas?
Cancel each other.
So for the first term, I'm left with sine alpha over cos alpha. Now I need to plus the second term. What do you notice about the second term? If I've got cos alpha sine beta divided by cos alpha sine beta, what happens to the cos alpha?
They cancel each other.
Leaving me with sine beta over cos beta. Now this, of course, is all over. And if we take the first term, cos alpha cos beta over cos alpha cos beta is just?
10.
No, cos alpha cos beta over sine cos alpha cos beta is just?
Same as the other side.
It's just 1. Right? Cos alpha divided by cos alpha and cos beta divided by cos beta.
Oh, why am I like this? Okay.
And then you've got minus. Now in this case, you've got sine alpha sine beta over cos alpha cos beta. Does anything cancel?
No.
No. But you notice you've got a
10.
sine alpha over cos alpha, which will be a 10, and also a sine beta over cos beta, right? So that means this thing becomes a tan alpha. This thing becomes a tan beta. I'm going to write this horizontally now. And that's just 1 minus tan alpha tan beta. And that is tan of alpha minus beta.
Wow. Okay.
Now I'm just showing you that so you kind of know what you can do with your trig sort of identities and so on. All right, is everyone happy and done with this page?
One sec.
So let me know when you're done with this page.
I'm done.
I'm done too.
Me too.
All right, so of course, if I want to tan alpha minus beta, I could go for the sine of alpha minus beta formula, cosine alpha minus beta formula, of which we've already worked out both of them, and then do the whole thing all over again. And I could do that, and I would get the right answer if done correctly. Or the other option, given that we've already done all this work to get tan of alpha plus beta, to be clear, that should be a plus. I'm not sure why there's a minus there. It's plus on the left, right? It's a plus, right? There's a plus, all right? Fix that, that's a plus. Now, we could literally do all the work all over again the same way, except with the minus formulas, or we can kind of cheat and just, do the same thing as we did with the negative and make this a negative beta, and then use this formula so the alpha doesn't change, but tan beta will become tan of negative beta, and that will give me the minus version, which basically means the minus version in green, that will become negative, this will become negative, and this will become positive. So again, you can go and do that for homework if you like. I've more or less shown you enough similar questions there where you should be able to work that out. But basically tan of negative beta is negative tan beta, so that will change. Was that clear to everyone?
Yeah.
All right, so therefore, we have effectively worked out through your definitions and a bit of geometry and a bit of trig rules with all your identities that you've done before, basically we have the following things, all right? And if you look at them, they're kind of all very similar to their pair. So one thing that I suppose people often kind of do is kind of group them together. You can see the form is all the same. So if it's positive, in the case of sine, it's positive. If it's negative, in the case of sine, it's negative. Similarly, for cosine, in the case of cosine, it's the other way around. If it's positive, it's negative. But if it's negative, it's positive. And for tan, similar things can be done. So if that was positive, that's positive and that's negative. If it was negative, then that's negative and that's positive. And so forth. Does that make sense?
Yes.
All right. So now I'm going to see if I want to work out sine of 2 theta. Do you guys see how I might be able to do this? How I might, so forgetting alpha and beta, but now I just want 2 theta, double theta. Do you guys see how I could do this?
Theta plus theta.
Exactly, right? So we could kind of use this one on the top. Sine of alpha plus beta is sine alpha cos beta plus cos alpha sine beta. But I could think of it as, well, theta plus, another theta, right? 2 theta is just theta plus theta. And if you like, you can think of this angle here as alpha and this angle here as beta. I mean, the rules on the left work for any angle, right? And so it doesn't matter if they're the same. So we literally could just use the formula on the left with theta plus theta. And if you do that, can you all quickly do that and see what you get? Simplify if you can. Okay, Jocelyn, are you done?
I'm not sure if this is correct.
What did you get?
2 sine theta and then cos theta.
Do you agree with that, Tiffany?
Sorry, what?
So Jocelyn said she got 2 sine theta cos theta. Do you agree with that?
Yeah.
Yep. Paris, do you agree with that?
Mhm.
No, you don't?
Isn't it just 0?
No, you used the wrong one.
Oh,
Right? It's plus, right? It's a plus. So you probably took the minus one.
I'm so confused. One sec.
It's a plus. It's definitely not 0. You're suggesting sine of any angle that is even is 0, which is definitely,
Copy it wrong.
yeah. And that's and it's not just any angle that's even, because if I made theta a half, you're saying sine of any angle is 0 basically. And that's not true. So yes, 2 sine theta cos theta is indeed correct. All right. So you can probably see where we're heading with this. So that's correct. Now you can probably do something similar with cosine 2 theta. So can you guys tell me what you get with that? Tiffany, when you're done, let me know what you get. But yeah, you just use the same idea, right? Theta plus theta.
I'm done.
All right, what did you get?
2 cos theta minus 2 sine theta.
You might want to check that. Jocelyn, are you done?
Yeah.
What did you get? The same thing or different?
I got 1 minus 2 sine squared theta.
Now that is correct, but that wasn't the answer I expected you to give me. How did you get there? Just so I know.
Like cos squared theta minus sine squared theta.
Oh, okay. And then you just, okay. You went further. Okay. I was not expecting that, but that's fine. So the first answer you should have got is cos squared minus sine squared. When you subbed it in, you should have got cos squared theta minus sine squared theta. So remember, cosine times cosine is cos squared, not 2 cos theta, and similarly for sine times sine. And I think that's where you went wrong. Paris, is this what you got as well?
Yeah, that's what I got.
All right. And then what Jocelyn did is she said it's 1 minus 2 sine squared theta. So you guys remember from your work from last week, right? Cos squared is 1 minus sine squared, right? So therefore, it's also equal to 1 minus 2 sine squared theta. And as I said, that is correct. But I suppose I was initially expecting this answer as the first answer. All right. So this is cos squared minus sine squared, which is correct. If you want to express it all in terms of sine squared, then it's 1 minus 2 sine squared. That's correct. Now, if I want to express it all in terms of cos squared, what would I do? I want it in terms of cos squared, no sine squared.
Cos square theta minus. Is it? Oh. Wait, what?
So we showed an example where we changed it from cos squared to sine squared. Now, if I want it in terms of cos squared only, I would need to change the sine squared to cos squared, right? So,
Cos square theta minus 1 minus cos, cos theta.
right? So if I start from the first line, I could do it this way. And then hopefully you can see that's a plus, all right? Meaning it's 2 cos squared theta minus 1.
Yeah.
So in the case of cosine 2 theta, there are 3 versions that are important. And actually, it's usually the latter 2 that are more important usually. Right? Now you can do the same with tan. It should be hopefully fairly clear that this will be the answer if you go ahead and do it. Okay. So let me know when you guys are done with this page. Are you guys done?
Yeah.
I'm done.
Tiffany?
Sorry, I'm in the middle of tutoring. Yeah, sorry.
Do you need this page still?
Oh yeah, I just took a picture of it.
Okay. So really, what that means then is you've got all of those things we listed earlier, all right? And so those are more or less the key things that, you know, we've proven how we got those results, and you have all of those results of sine, cos, tan, of alpha plus beta, or alpha minus beta, or of 2 theta as well.